Okay, now we're going to do some confidence interval questions using StatCrunch. A manager at the call center wants to estimate the mean time a representative spends on customer call. A random sample of 25 calls, so that's N, yields a sample mean. He says a sample mean, so that's X bar of 4.5 minutes, and a sample standard deviation S of 1.2 minutes. The question is, so we have the sample size 25, the sample mean is 4.5, and the standard deviation is 1.2. Construct a 95% confidence interval for the true mean call time. Let's construct the interval first using StatCrunch. So we go to stat. Now, when you're doing confidence interval for the means, you have to choose between Z-stats and T-stats. We choose T distribution when the sample standard deviation is given to us, and we use Z-stats when he gives us the population standard deviation. So if he says assume that the population standard deviation is 1.2 in this question, instead of saying sample standard deviation, use Z. But since he didn't mention population standard deviation, it's T. So we use T. It's only one sample, guys, with summary. I don't have the actual data. Okay, let me show you right here. Okay, so the sample mean is 4.5. The sample standard deviation is 1.2. The sample size, guys, is 25. And we need to select the confidence level. And what was the confidence level in the question? The confidence level was 95, so just select the confidence level here and hit compute, and here's your interval. 4.00, and the upper limit is 5. So it's actually between 4 and 5. So the mean is between 4 and 5. That's the answer for part A. How do you interpret the interval? Interpret the 95% confidence interval. So you say, with 95% confidence, we can say that the true mean time a representative spends on a customer call is between 4 minutes and 5 minutes. C. If the manager wanted to be 99% confident, would the interval be wider or narrower? This is how it works, guys. As you increase the confidence level, the interval will become wider. So if we try to do a 99% confidence interval, guys, you're gonna notice it's a wider interval. So it widens. And when you decrease the confidence level, the interval will become narrower. Okay? And as you can see, here are the steps for StatCrunch and how to use StatCrunch to construct a confidence interval. Now we have a confidence interval question for the proportion. A city council is trying to determine if majority more than 50% of residents favor a new bike lane initiative. A random sample of 250 residents found that 145 of them support the initiative. So the sample size is 250 and the number of successes X is 145. Calculate the sample proportion P hat of residents who support the initiative. The sample proportion P hat means 145 is what percent of 250. So you just divide 145 by 250 and you get the sample proportion. You can see, guys, I divide 145 by 250, I get 0.58. The sample proportion is 58%. Now, part B, construct a 95% confidence interval for the true population proportion for residents who support the initiative. So let me show you how to use StatCrunch. So you go to Stat, and since it's about the proportion, just select the proportion stats, one sample with summary. And let me just lower this a little bit so you can see the screen. Okay, number of successes, how many 145 for the number of successes, 250 for the number of observation. And guys, you need to select the confidence level, which is 95%. And then you can click on compute. Let me show you compute. It's right there. And here you go. Lower limit is 51.9% and upper limit is 0.641 or 64.1%. If he asks you to interpret this one in words, this is how you interpret this one. With 95% confidence, we can say that the true proportion of residents who favor this initiative, the new bike lane, is between 51.9% and 64.1%. And then the last question he asked, use the confidence interval to determine if the majority will be supporting this initiative. Majority, guys, means more than 50%. And as you notice, this interval only contains values that are bigger than 50%. So based on the interval, yes, it is likely that the majority will support this initiative. Now we're going to learn about how to construct confidence interval for the mean. An airline is investigating the weight of a carry-on luggage. The population standard deviation is unknown. So since he didn't give us the population standard deviation, then it is a T, not Z. A random sample of 45, so that's N, passengers, has a sample mean of 16.8 pounds. So this is X bar, the sample mean. And then a sample standard deviation of 3.2, that's S. And explain why the central limit theorem allows us to construct the interval. You notice, guys, he didn't say that the original population of weights of carry-on luggage is normally distributed. But if the sample size is 30 or more, we don't care what the original population is like. All we need is a sample size of 30 or more to be able to construct a confidence interval for the mean. So the central limit theorem, if the sample size is less than 30, we need to make sure that the original population is normally distributed. But if we don't know nothing about the original population, all we need is a sample size of 30 or more, which is the case here. It's 45. Construct a 99% confidence interval for the three mean carry-on luggage weight. Let me show you how to construct this. Very straight forward. Stat crunch. I'm gonna close this. We're gonna go to stat, T stat, not Z stat, one sample with summary. Okay. What is the sample mean, guys? 16.8. What is the sample standard deviation? Is 3.2, I believe. I double check. The sample size is 45. And he wants us to create a 99% confidence interval. So if I hit compute, guys, this is the interval I get. So if he asks, the mean is between 15.5 pounds and 18.08 pounds. If he asks you to interpret the answer, you say with 99% confidence, we can say that the true mean weight of a carry-on luggage is between 15.5 pounds and 18.08 pounds. I provided you with the information how to use StatCrunch right here, guys. T-stat, one sample with summary, enter the value of X bar as Sn and select the confidence level and then hit compute. Here's another question. In a recent survey, 320 out of 500 residents in a city reported using public transportation at least once a week. Calculate the sample proportion P hat. P hat, guys, is 320 divided by 500. It's X over N, which is going to be 0.64. Of residents who use public transportation. B. Construct a 90% confidence interval for the true proportion of all city residents who use public transportation weekly. To construct the interval, you need the 320, which is X, the 500, which is N, the confidence level, which is 90%. So stat proportion, it's about one sample with summary. Number of successes, guys, is 320. Number of observation is the sample size, which is 500. And he wants a confidence interval for 90. And scroll down and hit compute. And here's the interval. 0.605 and 675. So if I want to interpret this one, I say with 90% confidence, we can say that the true proportion is between 60.5% and 67.5%. Okay, next question. A research group is planning a survey to estimate the true proportion P of college students who use a certain study app. They want to be 90%, 95% confident that the sample proportion P hat is within a 3% of margin of error. That means he's giving you the margin of error, guys, here it's 0.03, and he wants the sample size. First of all, he's asking what's the critical Z value that corresponds to 95% confidence level. Let me show you how to find those critical numbers first. So you go to calculators, you select the normal calculator again. Let me show you that. You make sure you have a 0 and 1 in there, and you just select between. And if you want to figure out the critical number for a 90%, 95% confidence, you just do 0.95 here, which is 1.96. For 90% confident, guys, it's 1.645. For 99, it's 2.576. I strongly recommend that you try to memorize those critical numbers for 90%, 95%, and 99% confidence level, and they are needed in order to compute the minimum sample size required to estimate the proportion. So for B, what is the minimum sample size required to meet this specification? Means 95% confidence level and a margin of error of 0.03, assuming that we have no preliminary estimate of the proportion. So there is a formula. I will provide the formula if you need it. I don't expect the students to memorize that one. So let me put the formula here and show you how to proceed from there. So for 95% confidence, we have Z equals 1.96 as I showed you using the normal calculator. We have E, the margin of error, which is 0.03. And in order to find the minimum sample size, if we don't know any information about P hat, then this is how you do it. So let me just show you here. This is the formula. P hat times Q hat, which is 1 minus P hat, this, which is going to be, since he didn't give me P hat, we use 0.5, and we use for Q hat, the probability of failure is 0.5. E is 0. ZC is 1.96, guys, divided by 0.03. Let me compute the answer and see what we come up with. So if you do 0.5 times 0.5 times quantity square 1.96 divided by 0.03, you'll get 1067.11. But because it is a sample size, you need to round it up. Always round up. The answer would be 1068. C. If a small pilot study suggested a preliminary estimate P hat of 0.2, this time, guys, is given us P hat, which is 0.2. We cannot use 0.5, 0.5. So we're going to use 0.2 for P hat and 0.8 for Q hat. Q hat is a probability of failure. It's 1 minus P hat, which is 1 minus 0.2. What would be the minimum sample size? So let's show you. So this time n will be 0.2 for probability of success, 0.8 for probability of failure, which is 1 minus 0.2, 1.96 for Z, and 0.03 for E. If you do the math, guys, it's going to be 682.95. And since we have to round up to the next whole number, it will be 683.